Okay. This lecture I'm planning to solve question 1, and then this example was solved about 2 years ago in mock exam question. Okay. First of all, I want to read the question. A wood beam in subject to point load, and its value of the point load is 12 kilonewton. In the question, principal stress on point A is needed, and also orientation of the principal stress or orientation angle of the principal stress is needed in the example. Okay. First of all, I want to write the strategy of how I can solve the example. We have 2 steps. The first steps, or 3 steps, it doesn't matter. First of all, just find internal forces. First step. Second step, find internal stresses. Okay. Then find principal stresses and their orientation. Just 3 steps we will use. First of all, I want to start with the internal forces. Just, this step related to your previous knowledge in static course. You know how we can calculate to moment, shear force, and bending moment. Okay. First of all, I want to look at my system. I want to draw the free body diagram. Okay. This is beam. I assume that's a line. Length of the beam is 4 meters. There's a point load on this beam. That's 12 kilonewton. Okay, I don't want to write the unit. Okay, then left end of the beam is the roller support. Therefore, I need to write just only one direction as vertical direction. Okay, up position or down position, it doesn't matter. I assume that this is up position. Okay, in this place we have 2 internal forces, because right on the right end of the beam we have a beam support. Okay, I want to symbolize the first term is, I don't know. No, I can't see is there any numbering in here? Okay. This point is point A in the question. Okay. This point B and point C, like this. My assumptions. So, okay, I can pass the question. Okay. So also position A is needed in the question, which what means how many meter? 2 meters. Okay. This length is 2 meters. This 1 meter. This part is, I think, 5 meters. Let me check. No, 4 meters. Sorry, so total length is 7. Okay, not 8. So this is related to statics. Is anyone help me to calculate? Is there any shortcut or long way? Which one do you prefer? Shortcut or long way to calculate? So, which one do you prefer? No, silence. Okay.
Long way, maybe.
Okay, long way. It's okay. So we have, this is the statically determined beam system, because we have 1, 2, 3 unknowns. I symbolize with this one is the direction B, Cy, and Cx value. 1, 2, 3 unknown. We have 3 equations. Sigma fx is equal to 0. Sigma fy is equal to 0. Sigma moment any point on the beam is equal to 0, but we prefer end points because we know the end points, there's no internal fx occurrence endpoint. Therefore, I don't need to write any additional unknowns in these points. Therefore, in moment, which one, for example, and c is equal to 0. So 3 equation, 3 unknown, we can solve. So sigma fx equal to 0, you can easily see there's only one term available on x direction, cx, okay. I want the x direction is positive, okay. So cx is equal to 0. So if this cx is equal to 0, I don't need to write cx. I can erase the cx term. Then on free body diagram, okay. So we have sigma fy is equal to 0, moment equal to 0. I want to start with the moment. I said the mc is equal to 0, so I take counterclockwise direction is positive. B force rotates V on clockwise direction. Therefore, I write the negative V times moment arm is, you can see, 7. This should be 4, so that the total length is 7. V times 7 moment arm, okay. And also we have a point load, 12 kilonewton rotates counterclockwise. Therefore, this should be positive. 12 times 4, okay. One more term cy is available. You know, you can see moment arm of cy is equal to 0 because cy's directions pass through to the point c, so cy cannot make moment. So I don't need to write cy. This term should be is equal to 0, okay. I don't have enough space, that's why I put to 0 in outside. So you can see V is equal to 48 divided by 7. I have a calculator, okay. I don't need to write to look at the solution manner, so I can follow my hand calculation. 48 divided by 7 is 6.85 or 686 kilonewton. I don't want to write the units right now, okay. But I don't forget the units, okay. So I found the B and sigma and y is equal to 0. You know, I want to use this equation downside. I want to write. So B plus cy. I want to take this one is a positive minus 12 is equal to 0. So the cy is equal to 12 minus 6.86 is equal to, I can calculate in my mind by using my mind, 5.90 that 40 kilonewton. Okay. Do you think did I make any computational mistake or error? Do you think? Is it good calculations? Would you like to check for me? Benim için kontrol eder misiniz? Var mı sıkıntı? Is there any problem in the calculations?
Yok sanırım hocam, doğru.
Okay. Çünkü hatalı gidersek geri kalan komple hatalı gideceği için emin olmak istiyorum. Okay. Sanki doğru gibi gözüküyor. This is a long way. Shortcut is maybe you can remember the high school. Okay. Hatırlayan var mı from high school? You know, this moment arm is 4, this moment arm is 3. Okay, total is 7. So we write 12 is equal to 12 times, okay, this arm 4 divided by 7. B term we can calculate like this. C term we can calculate 12 times using this arm 3 divided by 7. Same value, I think that. Doğru mu arkadaşlar? Hatırlıyor musunuz lisede biz stratejiyi? Ters yöndekileri dağıtıyorduk böyle. No one can remember? Hatırlayamıyor musunuz? Biliyor muydunuz bunu? Do you know this? Silence. No one.
Hocam vardı ama ben ezberlememiştim.
Ezberlenecek bir şey yok. Şöyle bakıyorsunuz. Eğer böyle bir point load varsa, okay, böyle de 2 tane force varsa, bunlar diğer armla orantılı olarak paylaşılır. Bu altındaki mesafe değil, diğer mesafeyi alıyorsunuz, çarpıyorsunuz, toplam mesafeyi bölüyorsunuz. Bu kadar basit. Ama hani bu da çok hani atıyor, uçar kaçar bir şey değil. Yani bu general solution. This is the special case. Okay. First step is finished. Not finished because we need to find the internal forces on point A. So I need to cut from point A. Okay, this is point A, and I am taking the left part. Okay, therefore I need to write to B force. What is the value of the B force? 6.86. Both B and C values are positive. What does it mean? Positive means that our assumption directions, assumption ways are correct. So I don't need to change direction of these forces. So I write to point B. Okay, this distance is given 3. Let me check. Am I doing mistake or not? Yok, it's okay. 2 mi? 2'ymiş bak. I made a mistake. 3. This one is 2. Okay. Oh, this is written in here. I'm blind sometimes. Okay. So I need to write to which. Is that enough? These forces for free body diagram, do you think? No. I need to write to internal forces or moments. How many internal forces on the beam? Do you know this? 1, 2, 3. Do you know? Bilen var mı? Silence again. I can answer for you. 3. First one is the normal force.
Normal, shear and moment.
Yes. Sonunda. Thank you. Yani sonunda derken yani seni eleştirisel anlamda söylemiyorum. Thank you so much. So this one as we have 3 internal effects, internal forces and moments. So again, this is the system. To this system, we have 3 equations. Okay, sigma fx equal to 0, sigma fy equal to 0, and any point I prefer to moment A, okay, point A, okay, moment on point A is equal to 0. I can use these terms in here, okay, like this. Okay, first of all, I want to start with the sigma x. You can see on x direction, there is no force except normal force. So normal force is equal to 0. Okay. I want to write to continue this sigma fy equal to 0. You can see I'm taking this direction is positive. 6.86 minus V as the shear force we need that is equal to what? 0. So shear force is equal to 6.86. So our assumption, not assumption. You know, this direction is not assumption. Bunlar nedir arkadaşlar? Bu diyagramları çizmek için oluşturduğumuz ne denir? Way'ler. we have to remember or we have to memorize. Biliyor muydunuz this direction'ları, bu direction'ların böyle olduğunu statik dersinde mutlaka bilmeniz gerekiyor. Unutmayın. Left'ten alırsanız bu şekilde,
Evet,
on
hocam.
right, right'te ise tam tersi oluyor. Right'ten alacaktık. Normal force böyle, shear force böyle, moment da böyle olur. Tamam mı arkadaşlar? Okay, let's continue. Just I take moments not seen. We have just on one point and not one point. Okay, I want to use moment A on point A. Okay, so sigma MA is equal to 0. I want to write two forces. I take the counterclockwise as positive. 6.86. Moment arm is 2. Okay. This rotates clockwise direction, therefore I write negative. Okay. So I have only one term as moment in here. I write this moment. Okay. Just shear force does not produce moment because shear force direction pass through to point A. Therefore, I don't need to write to shear force term in our equation. Okay, so it's 0. You can see moment is equal to 13 point. It's not like this. I hope. Yes. Unit is kilometer. This unit is kilometer. Okay. Do you have any problem up to now? Okay.
No problem.
No, I
No
don't.
problem. So our internal forces, normal force is equal to 0. Okay. Shear force is 6.86 and moment is 13.72. So can I erase this part? Okay. So if I take a cross section, okay, still I want to write it bigger, okay. This is the cross section A, okay. This is the natural axis like this, okay. Our internal effects, we have a shear force, down direction, okay, 6.86, and we have a moment, its value is 13.72. Okay? So first step is finished. Okay, let's continue with the next section, next term. Okay. First of all, I want to find the location of the A. You can see location of the A is there's a this 75 millimeter upper side of the bottom line, upper and like this. Okay, its drawing is better. Sometimes I can produce any sentences to define the location of A. Okay. Okay. So first of all, I want to draw the cross section. Okay. Let me check the cross section, not this one. Yes. 300 millimeter, 300 millimeter height, and 200 millimeter width. Okay. I want to write in here. This one. Yes. This one is 200. This one is 300. Okay. And location of A is 25. So the bottom of the natural axis. So this value is also 7.5, and this one is 150. Isn't it? Can you read the values? Maybe you cannot read 150, but you can compute. It is not complicated. 150. Okay. So I found the location of the A. Okay. Now we can ready to pass step 2. Find two stresses. Which type of stresses occur on cross-section, this cross-section A? First of all, I can ask you, is moment is occur or not? Does moment occur or not on this section? Yes or no? Moment oluşur mu arkadaşlar?
It does not occur.
Yanlış cevap, wrong answer, occur. Normal stress occur. Normal stress is due to bending. Okay, we have no normal force. Yes, correct. So I can say there is no normal force occurs due to axial force. Yes, correct term. But normal force occurs due to the bend. Do you know this formulation? Do you remember? M divided by moment of inertia times 1. Chapter 8'te bunu tekrar etmiştik değil mi arkadaşlar? Hatırlıyorsunuz değil mi? Unuttunuz. Okay.
Evet hatırlıyorum.
Moment neydi arkadaşlar? Bending moment. Value var mı arkadaşlar? What is the value? 30.72. We know the moment. Okay. What does it mean mile? Do you remember can explain in Turkish or in English? It doesn't matter for me. Mile kaç arkadaşlar? Y is the distance. Distance of what? Distance between the point A and natural axis. So burada distance kaç arkadaşlar? Hangi distance alacağız? Şu distance alacağız. Bu distance kaç arkadaşlar? 75. So I can easily calculate y. Just only one term is I need to calculate. Which one? Moment of inertia. Can I calculate? Yes. So now I can say that I can calculate right now. So I want to write the question mark. Okay? Problem var mı arkadaşlar buraya kadar? Okay. Is there any additional stress occur on this cross section? Var mı additional stress? Do you think? Sigma. Also, I have a tau. Tau due to torque moment. Is there any torque moment available in this cross section? Torque'un ne olduğunu biliyorsunuz değil mi arkadaşlar? Torque. Vurulma. Is there any torque available in this cross section? Torque var mı arkadaşlar? Vurulma.
No.
No. Peki, we have a shear force. Shear force, which type of stress occur due to shear force? Normal or shear? Shear stress, shear force, sanki shear olması lazım gibi değil mi arkadaşlar? Değil mi? Do you remember? Shear force'dan oluşan shear stress'i hatırlayan var mı? I can help you. Bir kere shear force olması lazım. Shear force divided by moment of inertia times Q times T. Okay? So I have already calculated the shear force in here. Okay? So if I calculate the moment of inertia, I can calculate the moment of inertia. Okay. Do you remember the Q? Q, what does it mean, Q? Q is the moment of inertia. Okay. So the last term is T. What does it mean, T? T is the thickness. Okay? Thickness of the section. So I can easily see the thickness of the section is 200. So I can compute the T. Okay. So I need to calculate three terms before calculating stress. First term is moment of inertia. Second term is area moment of inertia. Okay? Şimdilik I need to raise this part and I need to calculate moment of inertia. What is the moment of inertia of two rectangular cross section? Neyse, bildiğinizi varsayıyorum. B times
1/12 times BH QPS.
Thank you so much. Thank you so much, Buse. Like this, okay. So I want to write the 200. Okay. So H is the 300 cube divided by 12. Okay. So I need a calculator. 200 times 300 cube divided by 12 is equal to 4.5 10 to the power 8. Unit is millimeter power 4. Okay. So I compute moment of inertia. Okay. Now I need to calculate the Q on point A. How we calculate the Q? Maybe you remember that. Y bar A times area A. What does it mean here in terms? I need to show you on diagram. Okay. This is my cross section. Okay. This is the natural axis. Okay. This is my point A. Okay. Area is this shaded term. Okay. This one is area A. Okay. And also this is the centroid of the shaded area. Okay. And I want to write like C. Okay. Distance between the point C and point A is to Y A. Oh. So area A, how we can compute? You know, this one is 150, half of the 225. So this length is 225. You know, this length is 200. So area A is equal to 225 times 200 is equal to 450 like this. 45,000. Okay. The unit is millimeter square. YA, what is the value of YA? Is L1 half B. Okay. Maybe I can show you. Okay, sorry that. Let me go. I made a mistake. YA is not distance from here to here. Okay. YA is equal to distance from the centroid to natural axis, not here. Sorry that I made a mistake. This is my fault. Okay, sorry that. YA is this distance. How we can compute? Is it hard or not? I think that this is, I can compute this length. What does it mean? This is 225 divided by 2. Total length is 150 available here. So 150 minus 225 divided by 2. So bunu yarıya bölersek 112.5 subtract from 50, 37.5. 5 millimeter. I think that like this. Is it correct arkadaşlar? Doğru mu? Hata yaptın mı sizce?
Hayır hocam.
Okay. So QA is equal to 45,000 times 37.5. So I need a calculator. I don't have enough ability to calculate in my mind, in my head. Okay. 1.687 10 power 6 unit is millimeter cube. Okay. Do you have any question for calculation Q and moment of inertia?
No question.
Okay. So I need to erase this part. Please record these values. Okay. No, you don't need to record. Şurayı silersen, şunları bırakırsan sadece. Okay. So moment of inertia is 4.5 power 8 millimeter, or just Q8 is equal to 1.6875 millimeter. So I am ready to calculate to shear and bending moments. Okay, normal stresses, not moments. Sorry. Sometimes I'm using different notation. Bending stress and shear stress. Which one? Stress or normal stress? Normal stress.
Normal.
Okay. Sigma is equal to, you remember that the M. What is the value of the M? M is 13.72 unit. You can see kilonewton meter. Okay. So this unit is millimeter. So I make a choice. I have to make choice. Which units I need to use? Hangisini isterseniz? Hangi uniti kullanalım? Kilonewton milimetrede mi kalalım? Yoksa Newton milimetre mi?
Kilonewton meter.
Kilonewton meter. This is meaning that the kilopascal. The second one is Newton millimeter. Is the megapascal. So you choose 2 kilopascal. Okay. So I write to 13.72 kilonewton meter. So I don't need to make any unit conversion. So divided by 4.5 10 to the power 8 millimeter. I need to convert to meter. Which term I need to multiply? Which value? Anyone guess for me? Tahmin etmek isteyen var mı? Does anyone want to make a guess? Make an assumption? Size yardımcı olayım. 10 to the power minus what? 4, 8, 12. Okay. 12 arkadaşlar. Okay. This is the moment of inertia. So also I need to write to YA values. What is the value of YA? 75 is also meter. I need to convert to the, millimeter. I need to convert to the meter like this. Okay. Again, I need a calculator for this part. Okay. this divided by, in parentheses, 4.5 into power 8 times 10 to the power minus 12 multiplied by 75 times 10 to the power minus 3. Okay. My calculator like this. Okay, can you see? Görebiliyor musunuz? Zoomlayınca olmuyor. Neyse, never mind. Umarım doğrudur. Okay. 2,286.7 kPa, okay, kilopascal, kilonewton divided by millimeter. Okay, let's continue with the tau. Okay, and so you remember that first of all I want to write to B, the shear force 6.6. I prefer the kilonewton millimeter system, therefore I don't need to make any unit conversion, times what is the value of the Q? Q is the 1.6875. Burada 10 to power kaçtı arkadaşlar ya? 6 miydi? Burada yazıyoruz sonuçta. I forgot to write in here. Böyle değildi. 10 to power 6 millimeter cube. Okay. So 10 to power 6. Okay. So I need to make the unit conversion. Kaç olacak arkadaşlar sizce? Is anyone guess? Help me. Kaç? Yine sessizlik. Silence. 10 to power minus 3. Arkadaşlar çok mu yavaş gidiyorum? Do you think I'm going so slow? It's taking a little bit much time.
Hocam.
Yavaş. Yavaş, yani yavaş yapayım diyorum. Yoksa bunu 5 dakikada bitirmiştim ben bu soruyu da. Okay. I need to multiply by 10 to power minus 9 in order to make it convert from millimeter to meter. Okay. So again, I need to write the moment of inertia. I already calculated here. 4.5 10 to power 8 times 10 to power minus 12. Convert from millimeter to meter, and one term remaining, thickness. Remember, the thickness is 200 millimeter. Again, I need to convert to the meter. Böyle uzun uzun yazıyorum. Böyle hani bir sürü rakamlar varmış gibi kafamdan da hesaplayıp yazabilirdim. Tercih etmedim. I don't want to prefer like this strategy. I want to show all the details in the calculation. Okay. So 6.86 times 1.6875 10 to power 6 times 10 to power minus 9 divided in parentheses 4.5 times 10 to power 8 times 10 to power minus 12 times 200 times 10 to power minus 3. Let me check. Okay. Let me check. Yes. Correct. Yes. I can compute. After this calculation, I get 128.6 kilopascal. Okay, very well. So I calculated sigma and tau values, and step 2 is finished. Okay. Up to now, do you have any question? Is it clear?
Yes, it's clear.
Clear.
Yes, clear.
Okay, let's continue. So I need to record to shear and normal force values. That's what I want to write. Now I don't need to be in space. So and okay. Almost I need to erase my reports. Okay. So I have a sigma is equal to 2286.7 kPa. So is equal to 128.6 kPa. Okay, very well. Clean area, clean break. Okay, now I need to ask a question. First of all, I'm going to pass to step 3. You can see, stress transformation. First of all, I need to draw infinitely small element on point A, like this. This is an infinitely small element. Like this. Okay. Like I zoom this point and this infinitely small points becomes like this. Now I need to show stresses on infinitely small element. I assume this direction is x direction like this. Okay. Okay. What are the normal values? First of all, I can help you. As normal stress is perpendicular to surface, isn't it? So normal like this. Maybe you recognize that I didn't draw any arrow. I want to write the value 2286.7. So direction is positive x or negative x. In other words, as compression or tension. Is anyone guess for me? Does anyone guess for me? Tevfik, guess for me. Tension or compression? Like, okay, I need to help you. First of all, you need to look at this bending moment direction and look at the position of A. This is two important parameters. Okay.
Tension.
Tension, okay. Okay, I record your guess, okay. One different gas, compression is on, want to say hocam, not tension, compression.
Tension hocam.
Tension. Tension is correct arkadaşlar. Because you can see in this bending moment type, okay, bottom part, okay, bottom part, try to get out of the plane, okay, and this direction you can see, upper side, get inside, try to move inside of the plane cross section. Therefore, if I want to draw a shear force diagram like this, okay, this is the like this, okay. You can see, I'm sorry, this should be compression, okay. This term should be like this, okay. So my arrow should be like this. Okay. Now I can pass to the shear force. So what is the shear force direction? Maybe I can help you. Shear force direction perpendicular to surface. Which surface, my reference surface, is, you can see 1, 2, 3, 4 surfaces. Which surface I need to take? You can see I take infinitely small square, okay? My cross section is right side, isn't it? So my reference surface is this one. Therefore, I always consider the reference surface like this. Okay, what is the value of the shear force? Burada tension or compression I cannot say. In this part I cannot say tension or compression. I can say upside or down. Up direction or down direction. Which
Downward.
down direction, you can see the thing, you can see direction of the shear force is down direction, so shear stress should be down direction. Okay, so this value is 6.6. After using this value, I can write other shear force direction also like this. Okay, what about normal stress on y direction, sigma y? Is there any sigma y available in the system or not? Var mı arkadaşlar? Şurada bir yerde sigma y. Peki. Bir şey var mı? Söyleyeyim size, yardımcı olayım. No. Okay. Is there any compression available on the this part? Okay. Maybe I can assume, is there a axial force on y direction? In this case, there is no axial force. Okay. So I don't need to write any additional force on y direction, and now I can write our internal stress values. So I can say sigma x is equal to positive or negative? Positive. Okay. Sigma y is equal to 0. For xy, positive or negative? Do you remember how I can define this? This one is positive or negative? Okay, I need to help you. It's x shows the direction. Okay, direction is, you can see right direction. Therefore, x is the positive. Okay, y represents the x represents the surface. Okay. We have the positive x surface, therefore I write the positive, okay? Y represents the direction. You can see the direction. Direction is positive y or negative y. Is negative y. So multiplication of positive and negative is negative. So I need to write the negative 6.80. Böyle miydi dedi ya? Sorry. Of. 128.6. Sorry that I write to stress normal. Sorry, I write to shear force value. Now I should write the shear stress. Okay, my mistake. Okay, like this. Is it clear? Do you understand this drawing strategy? It's extremely important for you.
Yes, it's clear.
Very well. Now we can ready to make a stress transformation. Two strategies we have. First strategy is I need to show on slide. Okay, yes, I want to pass to slides. Okay. Sorry, where is it? This. Yes, this one. I can use this formulation. Okay. Just only apply this formulation. This is the first strategy. Second strategy is more circle. Okay. This one. I prefer to use the more circle. Okay. You know, this is the straightforward. Write to function or equation and put the values instead of the unknown terms in the equation, and we get the values. It is easy. Not easy, I think that it is a straightforward. Now I want to use the more circle. More circle strategies is also very simple. I need to lay this part arkadaşlar. Okay, this part is this part. Okay. On more circle, I need to pick 2 points. First of all, I need to draw sigma tau coordinate system. Okay, I need to pick 2 points. First point is sigma x negative tau xy. So sigma x you can see like this, 286.7. This system, okay. Negative tau xy, so tau xy is the negative, 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 positive. Therefore, is like this point, 128.6. So this is my first point. Okay. So I need to write the second point. Second point is, maybe I can write sigma x negative tau xy. Okay. Second point is sigma y tau xy. So sigma y is 0, you can see. Tau xy is negative 100. I don't need to write the value. So this is my second point. Okay. Sigma y positive tau xy. Okay. Like this. After that, after marking 2 points, I need to take this part and this part because I need enough space to do a moment one circle. Okay. I merge these 2 points. I draw a line between those 2 points. This is the diameter of my circle. Okay. Then I am ready to. First of all, I need to find the origin of the center of the. Sorry, not origin, center of the circle. How we can find this value? You already know this is the 2286.7. This is the 0. So what is this value? Is anyone guess for me? Kaç olur arkadaşlar? Sizce? Yarısı olur. Yes, half. 1143.4. Okay. So this length is 1143.4. Yarısı bu değil mi arkadaşlar? Yanlış hesaplamadım değil mi? Half of this value. You already know this value is 128.6. This is the 90 degree. Can I calculate this length? Half. Bunu hesaplayabilir miyim arkadaşlar? Silence again. Which theorem I need to use? Hangi teoremi kullanmam lazım? From geometry. Pisagor. Olabilir mi?
Olabilir.
Everyone go fly. Lose concentration in that. Okay, using Pisagor theorem, I can calculate R. You can see R is equal to square root. These terms, okay. And after calculating, I need a calculator. This is 1150.6. Okay. So this is the 100. 1150.6. Okay. So I need to place this triangle. Okay. Do you understand how I can find the R? Okay, it's so simple. Then I need to draw my circle. Okay, not the circle. Okay. Like this. Yes. This is the sigma 1. This is the sigma 2. Okay. How I can find the sigma 1? Okay. I already know the location of this point, 1134. So sigma 1 is equal to plus this length is 1. So 101 like this value, and this one is equal to 2293.94 just kPa. Okay. Sigma 2 is minus like R, and this value is minus 7.27 or 28. Okay. kPa. This is the R principal stresses. And what is the orientation or orientation angle? This is the R orientation angle, like this. Okay. So I need to compute. Okay. So tangent to theta P is equal to, okay, and you can see one this value divided by this value. Can you see? Okay. From formulation, I need to write the negative. Okay. After that, I can put my computer again. Trigonometry, tangent power minus 6 divided by 11.4. Again, my angle is 3 is equal to theta P is equal to minus 2.14 degree, and minus meaning that clockwise direction. Okay, you can see in the angle, you can see clockwise direction. Okay, this is the end of the question. Okay, do you have any question, especially in the last part? I think you didn't make any practice for the Mohr circle because I uploaded video for Mohr circle yesterday. So I can say I accept my mistake, my my mistake. Okay, so I apologize first of all, uploading video late. Okay, but I hope you understand my solution because it is not complicated. I'm using just only the geometry. If you are good at in geometry, okay, you can easily find these values, okay, or trigonometry. Do you have any question? Muhammad, do
No
you have any
question.
question? Berke? Yok.
No question.
No. Okay. Is it clear? Do you think? Especially in last part. Maybe some of it not clear. First of all, watch the video again, okay? And try to understand the missing part, okay? If you have a specific question, you can ask me, okay? It's our midterm exam like this, okay? You probably faced similar problems like this, okay? I think, we spent almost, more than 1 hour for solving this example. Okay, I think this is enough. Some of you asked a question. Sorry that I didn't solve your message. Thank you, Muhammed. Okay, arkadaşlar. See you on next week.
Hocam bir şey
Have a
sorayım.
nice day. I want to close the connection. I want to close the meeting. Okay.
Hocam bir şey sorabilir
Thank
miyim?
Bye bye.
Hocam Classroom olmadığı için ödevleri göremiyoruz da ödevleri nasıl yapacağız? Yani ödevleri
Aa.
sıralaması kaçtan olacak?
First of all, I didn't assign any homework up to now. Okay. I'm planning to upload your homeworks, okay? And you just only 2 homeworks whole semester, okay? I want to upload homeworks both Teams platform and LMS platform, in both platform. So you can reach to, I prefer to use Teams to reach to assignments, homework assignments. So don't worry about this. You can reach, okay? Mert, if you have any trouble to reach the homework assignments, okay, you can send me a message. I can send you in private email, okay, for you.
Tamam hocam, çok teşekkür ederim.
You're welcome. Okay, arkadaşlar. I'm first of all stop recording. Okay.